Simpson rule, approximate integration. Simpson rule, which is approximate for integration, is given by um, is approximately given by the left all over 3 into f of x naught into f of x naught plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus, it continues like that up to 2 f of xn minus 1, then plus 4 f of xn this is xn minus 2, then xn minus 1 up to plus f of xn, like that. So this is the integration, approximate integration by Simpson. The coefficient of the first one is 1, and then the coefficient of the last one is 1. But the coefficients in between alternate, so we have the coefficients 4, 2, 4, 2, 4, 2, like that. So in between, the coefficients will alternate from 4 to 2, 4, 2, 4, 2. But the coefficients are the extremes. The coefficient at the first function is 1, and then the last one, the coefficient is also 1. So this is the Simpson rules. Now I want us to apply this, to apply the Simpson rule, to be able to get the integral from 0 to 3, then 1 plus x squared dx, n equals to 6. Now, from the given equation, it means we are integrating from 0 to 3. We are integrating from 0 to 3, and then n equals to 6. Therefore, del x is given by b minus a over n. So from the given equation, our p equals to 3. Our p is 3. Our a equals to 0. Then our n equals to 6. Our n equals to 6. Therefore, del x will be equal to our b, which is 3 minus 0 all over 6, which equals to 3 all over 6, which is equals to a half. Equals to a half. Therefore, we divide this one. So our first, this is first, then our first half will be a half. Then we have a half plus a half, we have 1. Then 1 plus a half, we have 3 all over 2. 3 all over 2 plus a half. 3 all over 2 plus a half. So we have 3 over 2 plus a half. This is 4. So you have 4. This goes there. This goes there 2 times. It goes there 2 times 3. We have 6. 6 plus 2 there. 2 into 4, 2 times 1 is 2. So we have 8. 8. But the LCM of 2 is 2. The LCM is 2. 2 times 1. 1 times 3 is 3. Then 2 there 1 times 1, that is 1. So this is 4 over 2. So this is 2. Then 2 plus a half. 2 plus a half. The LCM is 2. 1 into 2 times 2 we have 4, plus 2 there is 1 times 1, so it's 5 over 2. So we have 5 over 2. Then we have 5 over 2 plus a half. 5 over 2 plus a half. So the LCM is 2. 2 there is 1, so we have 5 plus 1. So we have 6 over 2, which is 3. So we have 3 like that. So 3, we are now here. So we have 1, 2, 3, 4, 5, 6. So because we had 6 and 6, so we have 6. So meaning this is x. So meaning that we have 0, a half, we have 1, 3 over 2, we have 2, 5 over 2, and then we have 3. So this is our x0, our x1, our x2, our x3, x4, x5, x6, like that. So once we have all these, and then we can now rewrite the equation. So our integral of from 0 to 3 into 1 plus x squared dx, so will be equal to our del x over 3, del x equals to a half, so it will be a half all over 3 into our f of x. So we shall have f of x naught plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4 plus 4 f of x5, then lastly plus f of x6, like that. This is what we're gonna have. So we have this. So So you can see we have our x0 is 0, our x1 is a half, then our x3 is 3 over 2. Therefore, we now substitute in this the equation. So approximate is equal to a half divided by 3. We have 1 over 6 into now our x0, our f of x0. So we come here, our x0 is 0. So we shall have 1 plus our x naught is 0, so it will be 0 squared, like that, 0 squared plus, then plus 4 into our x1. Our x1 is a half, so it will be 1 plus a half, then squared, a half, then squared, then plus plus our x2, it will be 2 into x2. x2 is 1, so it will be 1 plus 1 squared, plus 1 squared, that is x2, then plus 4 into x3. x3 you can see it is 3 all over 2, so it will be 1 plus 3 all over 2 squared, like that, then plus 2 into our x4. Our x4 is 2, so it will be 1 plus 2 squared, then plus 4 into our x, our x5, 1 plus 5 over 2 squared, then lastly plus the last x6 will be now 1 plus 3 squared. Remember the coefficient of the last one is 1, and also the first one, the coefficient is 1. So this is what we have. 1 all over 6 into 1 plus 0 squared plus 4 into 1 plus 1 all over 2 squared, like that. So this one equals to 1 all over 6 into, so here we have 1 plus 0 squared, so it will be 1, then plus this is 4 times 1, we have 4, then plus 1 over 2 squared, this will be 1 all over 4 times this 4, so it will be 4 over 4, 4 over 4, then plus 2 times 2, 2 times 1 we have 2, plus 2 times 1 squared, it will be 1, so it will be plus 2, then plus here we have 4 times 1, it will be 4, then 4 times 3, it will be 9 all over 4, so 4 times 9, it will be plus 36 all over, this will be 4, then plus 2 times 1, it will be 2, then this is 2 squared, so 2 times 4 plus 8, then plus 4 times 1 will be 4, then 4 times 25 will be plus 100 over 4, then plus this will be 1 plus 9, like that. So this equals to 1 over 6 into, so 1 plus 1 plus 4 plus 1, so we have 5 plus 2 plus 2, that is 4 plus 4, that is 8 plus, this is 9, 2 plus 8, 10 plus 4, 14, plus 14, plus this is 25, plus that is 30, 35. So this equals to 1 over 6 into, 5 plus 8, that is 13, 13 plus 9, 13 plus 9, that is 2 and 1, 22, so we have 20, 22 plus 14 plus 14, this is 6, this is 3 plus that 5, 11 third 1, 7 1. So we have 71. So this equals to 71 all over 6. 71 all over 6. This is approximately 1. 6 goes into 7 1. Then we have we remain with 1. We have 11. 6 into 11. 6 into 11. 1. Rem 11. Rem 5. 6 into 5. 6 into 5. Into 50. It's around 8. So approximately this one is 12. Approximately, when you use the integration by Simpson, then we approximately have 12. So we can prove this by the integration that we know. For example, the equation was the integral from 0 to 3, 1 plus x squared, of course, dx. So from the integration that we all understand is that this one is the same as we are integrating. When you integrate this, you have x, then plus x cubed all over 3. Then of course we have the range is 3 to 0. So this equals to, we now keep putting the limits. So we have 3 plus 3 cubed, so this will be 20, 7 all over 3. Then of course minus, we substitute with 0, like that. So this equals to this 3 plus this is 9, which equals to 12. Thank you.